Hi, I'm Stephen with Fulham, here to share with you today our new programmable smart ballast line. We have two new smart ballasts we've just released, the SHS-4P and the SHS-15P. The SHS-4P has all the features you expect from our SunHorse ballast line, including LED indicators for both power to the ballast and the lamp, and a new remote switch, which is a feature we just added, all the certifications you need for both domestic and international business, 120 to 277 volt input, and 1 or 2 lamp operation. We've also added some incredible new features like programmability for the ballast from 400 milliamps to 800 milliamps with this SHS-4P, or 800 milliamps to 1.2 amps with the output of the SHS-15P. This one again can handle up to 100 watts of loads in either 1 or 2 lamp configurations, and the 15P can control up to 330 watts of load. We also added intelligence straight into the ballast, so this has a smart chip in it that you can access through this RJ12 connection. We've taken the input from our customers over 20 years in the UV space and made it possible for them to do so much more with the ballast, cutting components, reducing costs, and increasing features. Let's get into how you can use this in your product today. I'm going to show you a few of the features, so come along for the ride. Right here I have in front of me this panel which allows you to experience all the different features of this ballast using our new SunHorse Display. This display is a commercial grade display that could be used inside of your technology, or you could use your existing display to access the I2C chip in here directly through firmware. We can share that firmware schema with your team and help you develop a connection to the ballast directly. You can go one of two routes, and we want to enable you as an OEM to make a successful product either way. So reach out to your regional sales manager to learn more about that, or to get one of these panels and explore this directly as you will with me here in this video. So let's get started. Right here in front of me I have the SHS Display. Right now it's connected to an SHS-4P ballast inside of this unit with a lamp. Right now the lamp is off. I'm going to depower this unit and actually disconnect this display because I want to show you a few functions that you can do without having a display or without even plugging into the RJ12 connection. I mentioned earlier this remote switch. This is a dry contact switch that will allow power to remain in the ballast, have charged capacitors in the ballast, but will actually cut output to the lamp via a dry contact. So you just connect to this remote switch port right here, and then you can power the ballast, or you can take power away from the lamp while the ballast remains powered. So I'm just going to turn this on. You can see this display is disconnected here. This display gets power through 24 volts AC/DC, or 12 volts AC, or a USB-C connector, or this RJ12 to the ballast. Right now, the ballast is powered, as you can see from this ballast power signal. Here's the lamp power signal. So the ballast has power, but the lamp doesn't, because
this dry contact has the lamp off right now. If I open the dry contact, it will power the lamp on and the signal here will turn on. Or by closing the dry contact, it will disconnect the lamp and the ballast will remain powered.
So a really cool little feature that allows you to either make a safety interlock or connect to a control board, or perhaps disconnect a large group of ballasts without creating an inrush current problem. A really great feature that we added to give flexibility to OEMs who want to access some level of intelligence without having to use a display or an I2C. So I'm going to just connect really quickly this display again. It's going to go ahead and search. I'm going to remove power first just to give it a good reset. Add power again here. So it's powered up, it's connected to the ballast, it's searching for the node, and it's found the node. See there? The lamp is off. Let's go ahead and turn the lamp on, and that ballast, or that status of the lamp, will change. Here we have the lamp time and then the lamp status. And down below here we have the ballast time and the operating time. And then we have the digital input and the digital output setting. I'll explain more about that in a moment. We have the relay setting. It's a normally open, normally closed relay here. There's a digital input here and a digital output here. We'll go into those in a moment. The temperature of the ballast is listed here in 44°C. It has a little hour counter for how long you've deferred the end of the life. So you can put the end of the life right here into this display, and then you can snooze it the lamp when it hits its end of life. And then there's a node here. This is just identifying that this SHS-4 here connected to the I2C is node number 44. You can have up to 144 nodes connected to this display via I2C, and it can control them all as a group or individually. So it can take full advantage of the I2C protocol. So let's go into the menu and look at a little bit of the functionality here. Number one is the lamp, so let's go in this menu here and look at the lamp settings. You can add the lamp brand and part numbers, so whoever's servicing the lamp can understand what they need to replace it with. That can be added via the USB-C port here using a Smart Set software and a computer. That software is available through your Fulham Regional Sales Manager. You can see setting here, number 3 is the expected life. You can actually change the expected life of the lamp right in the software through the click of a button. So I've changed it from 8,000 hours to 3,000 hours. When it hits that 3,000 hours, it can trigger a few things. It can set an alarm off. I'm going to turn it back now to 8,000 hours. So really very easy, a super feature. Here's a notification that will go off when the lamp hits its end of life. So right now it's set to go off at the end of its lamp life. Let's just take a look here. I can turn that off so that there will be no visible alarm here. The visible alarm can be set through this setting. There's also an audible alarm that this has, it's called a buzzer. We'll see that later in the menu. So I'm going to turn this alarm back on. So now when the lamp reaches its end of life, it will have the alarm on. You see here this option for nodes. That just gives you the ability to decide, okay, do I want the end of all of my lamps to trigger the alarm, or just the one that's directly connected to this display now? So you can change the setting of which nodes trigger that setting. There's lamp service. This is where you can snooze the lamp if it's hit its end of life, now or later. And then there's the parameters of the lamp. This is a fun little menu where you're able to change the lamp on or off directly from the display. A very cool feature. There's also the ability to change the output current. This is kind of where you get into the futuristic type stuff. Being able to reprogram a ballast while it's connected to power, changing it from 800 milliamps down to 400 milliamps. You can see the light dim down there. And now I'll change it back to 800. These ballasts really are the ballast of the future. All this intelligence right in the ballast, directly connected, immediate access to it. It's an incredible, incredible product. So those are the lamp settings. We're going to go down one and look at ballast type. You can actually use this display with a non-smart ballast like the SHS-11 or the SHS-1 and take some of the lamp indicator signals into the ballast to trigger into the display to trigger certain things. We're going to leave that where it is because we have a smart ballast connected. So like I said earlier, there's a digital output and a digital input. You can change the functions of this. First of all, you can make it so that it reacts to all the ballasts or just any of the ballasts or one of the ballasts triggering that digital output. So right now we're going to look at the function and say, okay, what is this doing? It's giving us a 5-volt output when the lamp is on. If we want it to give us a 5-volt output when the lamp is off, we can actually change this over. So the lamp is on right now. I've changed the setting to give us 5 volts when the lamp is off, and so you can see here this 5-volt signal here has turned off now. I'm going to turn it back to give us 5 volts when the lamp is on. I've saved it and you can see it turned on because the lamp is on. Turn it back to give us 5 volts when the lamp is off. I'll take power off the lamp and it will give us those 5 volts right here at that digital output. So do you want 5 volts when the lamp is on, or do you want 5 volts when the lamp is off? You can change that setting right here. So I've set it back to give me 5 volts when the lamp is on. The digital input port allows you to take in a 5-volt signal to change the lamp status, or to create essentially a type of dry contact situation where you provide 5 volts to a dry contact or 5 volts to a relay, and then when that switches, it will react accordingly. So let's look at that for a minute on this input. So right now it's pulling up, meaning it's looking for 5 volts coming in, and when the 5 volts come in, it's going to turn the lamp on. So I'm going to remove those 5 volts right now, show you the lamp is going to shut off. Okay, so the lamp is off because it's no longer receiving 5 volts. I'm going to turn that back on for a minute. Let's change this around a little bit in terms of how it works. We're going to go ahead and say, okay, instead of looking for 5 volts, I want you to look for a pull down signal. And essentially that makes this a type of a dry contact situation where it's going to pull down 5 volts from it, and when it senses that there's a close contact on that pull down, it will turn the lamp on. So you can change that setting right here. A very cool function, a lot of flexibility to work with your existing controls and setup. I'm just going to change that back. Let the lamp turn back on there. You can change the relay and decide if you want it to be based on lamp status or the end of life hours. So right now it's set to change the relay over whenever the lamp turns on or off. So turn the lamp off, the relay switches over. Turn the lamp on, the relay switches back. You can actually change that to end of life instead. You can also add a sensor on or off here. You can change the audible buzzer on or off. Pretty powerful feature for an audible buzzer. Gather the node info, that's just reading the software on the ballast. Get the display info, the software on the display, and then the communication port, you can configure your diagnostics and addressing right here in this menu. So those are all the various features in this ballast. That's what this demo kit's meant to do. That's it for me today. Reach out to your sales manager today to get more and to learn more and to get one of these in your hands today to play with to add features to your product. Thank you.